Diodes are fundamental electronic components that allow current to flow solely in one direction while effectively blocking it in the reverse. Their basic structure consists of an anode and a cathode, which are crucial for this functionality. Different types of surface-mounted diodes, or SMD diodes, encompass standard, switching, rectifier, and Zener diodes. Each variant serves distinct purposes within electronic circuits, influencing their operational attributes significantly. Zener diodes are particularly noteworthy as they provide a stable reference voltage, which is vital in numerous electronic applications. Familiarity with their unique symbols is essential for accurately identifying their roles within a circuit. In addition, transient voltage suppressor (TVS) diodes act as rectifiers, adeptly managing large peak currents. Their functionality is crucial in protecting sensitive electronic components from voltage spikes. Light-emitting diodes, or LEDs, represent another significant category of diodes, known for emitting light when current traverses through them. They are integral to a wide range of electronic applications. Testing diodes requires a multimeter to assess their polarity and overall functionality. A properly functioning diode will exhibit a reading in one direction, while showing none in the opposite direction. Moreover, it is possible to distinguish various types of diodes, such as Zener and standard diodes, using their color bands. Familiarity with these color codes is beneficial in understanding their specific functions. Correct usage of a multimeter is vital for accurate diode testing. Ensuring that you probe the negative and positive terminals in the appropriate order allows for reliable readings and evaluations. Recognizing the diode terminals, namely the anode and cathode, is crucial for effective testing. This foundational knowledge enhances the ability to discern whether the diode operates as intended. To fully grasp the diode testing process, it is essential to verify readings while probes are connected to the cathode and anode. This step confirms the functional status of the diode. Short-key diodes, which incorporate multiple diodes, require several readings for thorough testing. This complexity underscores the importance of careful examination throughout the testing process. Lastly, recognizing the distinction between diodes and transistors is significant, particularly in terms of the expected readings. Transistors typically present varied readings between the collector and emitter. Testing diodes can be performed both in and out of the circuit using a multimeter equipped with a diode check function. This capability simplifies the troubleshooting process, offering significant advantages for electronics repairs. Diodes are designed to allow current to flow in one direction while exhibiting a forward voltage drop, an essential aspect for maintaining proper circuit function. This characteristic serves as a fundamental principle in semiconductor operation. Two prevalent types of diodes, standard silicon and Schottky, exhibit different forward voltage drops, influencing their applications in various circuits. Understanding these distinctions is vital for selecting the appropriate diode for specific needs. Relay coil resistance significantly impacts readings, with lower resistance yielding much lower readings across a diode. This property proves useful for effectively assessing diode functionality. Schottky diodes present a lower forward voltage drop compared to standard silicon diodes, typically ranging from 0.1 to 0.5 volts. This advantage reduces voltage loss in power supply designs, enhancing efficiency. Zener diodes necessitate a different testing methodology and cannot be evaluated using standard diode tests. For detailed guidance on effectively Zener diodes are characterized by specific symbols and functions. Testing them utilizes similar multimeter techniques, but readings can differ based on their unique characteristics. Moreover, SMD Zener diodes frequently appear in laptop motherboards. Understanding their testing procedures is essential for effectively troubleshooting electronic devices. Normal diodes are distinguished by their anode and cathode. It is vital to ensure proper probe placement for accurate multimeter readings during testing. To check a diode's functionality, the measurement of voltage drop is crucial, along with ensuring that no reading occurs when the probes are reversed. This result confirms a healthy diode. Zener diodes play a critical role in stabilizing current, and their testing follows the same principles as standard diodes. A good Zener diode will not show a reading when the probes are swapped. Surface mount diodes, often found in laptop motherboards, require accurate identification of their anodes and cathodes for effective testing. A positive reading confirms their functionality. Testing diodes entails checking the voltage drop while reversing the probes, which helps assess their condition. This process determines whether a diode is functioning properly or is potentially damaged. Diodes fulfill various roles such as protection and rectification within electronic devices. Recognizing their function in a circuit is vital for effective troubleshooting. Finally, the placement of diodes on a motherboard can significantly affect device performance. By understanding the location of protection diodes, one can prevent damage to sensitive components. Shortcut diodes typically reside in the secondary stage of flyback switch mode power supplies. Their correct placement is vital for effective circuit analysis. Additionally, grasping the thermal characteristics of shortcut diodes is essential for effective circuit design. These diodes produce heat, highlighting the need for efficient heat dissipation methods in electronic applications. Testing diodes with a multimeter yields clear readings that differentiate between standard and shortcut diodes. This method guarantees precise evaluations of diode functionality. Short-key diodes are engineered for rapid switching and low forward voltage drop, making them critical in specific applications. They minimize power loss in circuits, thereby enhancing overall efficiency. The video contrasts normal diodes with short-key diodes, emphasizing their differing voltage drop readings. This comparison is key to understanding their roles within electronic devices. In a motherboard configuration, diodes can exhibit various arrangements and LED layouts. Familiarity with these configurations aids in troubleshooting and ensures that replacements are executed accurately. Correct connection of diodes is paramount. Cathodes should be linked together to allow for precise testing. This arrangement significantly influences the outcomes during testing. Identifying a defective diode is relatively simple. If continuity or a buzzer sound is registered during testing, it signifies that replacement of the diode is necessary. Various diodes may possess differing internal structures, which can affect the testing methodology. Recognizing these variations is crucial for effectively diagnosing potential problems.